Hello, my amazing students. I know I am out today. It is a substitute teacher day, and I could not get sub coverage for math. That doesn't mean I'm going to let you guys hang. I'm going to record you guys a video. All right, guys, so today we're working on 3.04 proportional relationships. There is a link to this class kick. You can find it in the assignment 3.04 on Canvas or in the description of this YouTube video. Well, clearly we're recording. This is literally a recording. All right, guys, let's dive right into your warm up. I'm going to give you 3 minutes. Go ahead and pause the video for 3 minutes and complete your warm up. What this is asking us is what are the x and y intercepts? Pause now. All right, guys, you push play. You must be done with your warm up. Fantastic job. Let's take a look at this guy together. So, what are the x and y intercepts? Now, remember, we talked about this last week. Intercepts are where we intercept the line stated. All right, so the x-intercept is where we intercept or cross the x line. The y-intercept is where we intercept or cross the y line. So let's go ahead and complete x first. So what I'm going to do is I'm going to follow our line, and find that point where we hit the x. All right, let me grab my pen real quick. There is our point right there. And then you just need to identify what point is that x-intercept. Well, that x-intercept is at 4 for the x and 0 for the y. Because remember, by definition, our x-intercept is where y is 0. So we'll have value for x and nothing for y, because y is nothing when we're on the x line. All right, now let's find that y-intercept, okay? Let's find that y-intercept. And if I come down my line, bam, that's where I hit. I just clicked away screens. There we go. That's where I hit my y line, guys. All right, I'll try not to mess this up anymore. All right, so when we're looking at our y-intercept, it's where we hit our y line. Let me grab my pen really quick, and I'm just going to make a little arrow to show you where it's at. All right, and now we need to figure out the ordered pair for our y-intercept. So if we look at this, did we go anywhere for x? No, we did not. X is 0. By definition, at the y-intercept, the value of x will be 0. And then we need to find our y, which is at 3. So our point for our y-intercept will be 0, 3. All right, guys, this is what we are talking about today. We are talking about ratios and proportions, but they're not going to be this simple. So let's just do a quick review. This is stuff you guys should have already learned in previous years. You should know the definition of a ratio, and you should be able to convert it to a fraction and then to a decimal. But if you can't, let's just review this really quickly. So when we are dealing with ratios, okay? Ratio or proportions to a fraction. First of all, this is our ratio, okay? So let's just say we're talking about like dentists or something. So this could be like 1 in 4 dentists believe that chewing gum doesn't help your teeth. All right, so we would want to know the fraction of dentists that believe chewing gum does not assist in tooth health. So we would come over here and we would literally just replace the colon with a fraction bar. Boom, 1 goes on top, 4 goes on bottom. All right, now let's say we need to then convert that to a decimal. Well, remember, fractions are division in disguise. So all we need to do is go 1 divided by 4, 1 divided by 4, even plug it into your calculator, and we end up with 0.25, or 25/100ths. All right, guys, this is warm up number 2, and I just realized I neglected to mention that warm up number 1 was in class kick. It had the stars. So if there are stars in the upper right hand corner, that means it's in class kick. If not, it is not. All right, so for warm up number 2, we're just going to quickly rewrite these rations. Ay, ay, ay. Spell check, Miss Hill. Ratios. or proportions as fractions and as a decimal. And then you guys can't answer me in the chat because you're watching this on YouTube. So go ahead and just jot those down in your notes. Let's look at this first one together. We have 4 to 5, or 4 out of 5. To the rest of those dentists that believe that chewing gum does help your teeth. Okay, so first of all, let's put it in a fraction. Fraction, decimal. And then just for an extra challenge, let's also do percent. Okay, you don't have to do this if you don't remember it, but let's just also do that just so we can show how we could go from a ratio all the way to a percent. All right, so first, as a fraction, 4 to 5. 4 to 5. I just replace the colon with the fraction bar. All right, and then if I'm going to go from fraction to decimal, you guys already know how to do this. We just go 4 divided by 5, division in disguise. Read it top to bottom, 4 divided by 5. And that will equal 0.8, or 8/10 as our decimal equivalent. Now, do you remember how to turn that into a percentage? Bump this guy over 1, 2 times and write your percent symbol. This would be also equivalent to 80%. All right, let's look at the second one here. 9 to 10, or 9 out of 10. 9 out of 10 as a fraction would simply be 9 on top and 10 on bottom. I just replaced that colon with that fraction bar. Now for the next section, we need to read this as division in disguise. 9 divided by 10. And that will give us our decimal equivalent, which is going to be 0.9, or 9/10. As a percentage? That's right, it's 90%. Last but certainly not least is 50 out of 100. 50 out of 100. Now, some of you may already know what this one is, but we're going to look at it anyway. 50 out of 100 as a fraction would give us 50 on top and 100 on bottom. And then if we turned that into a decimal, we would have to go 50 divided by 100. And look at what you got on your calculator, guys, if you couldn't see it. Yeah, that's right. It's 1/2. It's 0.5, or 50%. Okay, now let's finally take a look at today's objectives. Today, what we're going to be doing is writing and identifying proportional relationships. Now, we're going to be focusing in on something called the unit rate. We'll talk more about that in just a moment. But let's just talk first about what is a proportion, or a proportional relationship. A proportional relationship between two variables, doesn't matter which two, x and y, z and q, doesn't matter, cost to number of rides. It's a relationship between two variables. One variable increases at a constant rate, and this is called the unit rate. And the other variable increases by 1. Okay, what does all this mean? What does all this unit rate nonsense mean? Well, let's look down here at my example with ride tickets. So we've all been to a carnival before. And if you haven't, just so you know, you have to pay a certain number of tickets to ride a carnival ride. Now we can see here that at this carnival, 1 ride costs 4 tickets, 2 rides cost 8 tickets, and so on and so forth. You can see our tickets increasing by a factor of 4. So if we were to set this up as proportions, honestly, we would just put little colons where that equal sign is. And then we come over here and we can set it up as fractions. And look at these. These are all equal to each other. 4 tickets for 1 ride, 8 tickets for 2 rides, 12 tickets for 3 rides, 16 tickets for 4 rides. That just means we have 4 tickets per ride. Per ride. That looks real similar to stuff we've been looking at in science. This is what we call the unit rate. When on the bottom of our fraction, or the second half of our ratio, we have a 1. That means we are in the single unit, which means if we come over here to our graph, we can see 1 ride, and I know it's right below the 5, but as we know, 4 is 1 less than 5. 1 ride costs us 4 tickets. 2 rides cost 8 tickets. And then if I wanted to know how many tickets 15 rides cost, let's just say it's way over here, all I would have to do is follow back. But you know what? We don't have numbers that big on this graph. So our unit rate tells us how much 1 unit is. It could be cost, it could be tickets, it could be really anything, but we're just looking at if there is one unit on the bottom of our fraction, that is our unit rate. I found another typo on this slide and I'm going to read it because it's just funny. The unit rage. Ah, rage. Just kidding. That's unit rate. Let's just fix that. Now it looks like a funny TG here. Well, I'm going to rewrite it. Rate. Wow. That looks like a first grader wrote it. Let's move on. Okay, so if we look at these, okay, a unit rate is when you have one of something and it is your denominator equal to 1. So remember how I've been talking about how there's that hidden denominator of 1 underneath every whole number? Yes, I know. You're getting activated in the memory banks now. Yeah, that's right. That's because 4 over 1 has a unit rate and it is 4 because 1 is on the bottom, and when we have one of these we get 4 of those. Down here 6 over 1, our unit rate would be 6. 1 on the bottom, 6 on the top. Unit rate when you have a 1 in your denominator. Oh no, it's decimal time. Let's just quit. I quit math forever. No, you don't quit math forever. We can totally handle decimals. First of all, don't panic. Just because you see a decimal doesn't mean you freak out. Sometimes your unit rate will be a decimal. Think money. Think about the cost per gallon of gas. That's always some weird number. Okay? So we will have decimals within our unit rates, which means that we will be dealing with fractions with decimals inside of them. And we've talked about those. It's okay. So here's a good example of it, okay? So if we have the cost to enter the fair is 2 tickets for $5. Find the cost of 1 ticket. We need the unit rate, 1 ticket. So check this out, guys. If we have to find Miss Hill's digital pen. There it is. Okay, so if we have, okay, $5 for 2 tickets, but I need to know how many dollars for 1 ticket. Well, this is just equivalent fractions. This is dealing with equivalent fractions, and we need to ask ourselves, what can I divide 2 by to get 1? Well, any number divided by itself is 1. So if I go 2 divided by 2 here, then I'll have 1. But anything you do to the bottom of a fraction, you also must do to the top. This is where we run into a decimal on top of our fraction. Because as we know, $5 divided by 2 is $2.50. But that's okay. We're going to leave it at $2.50 because that is the cost for 1 ticket. This is our ticket unit rate. All right, so we've discussed unit rates and what they do and what they are and how we turn ratios into them. Let's talk about graphing these bad boys. So when we are tackling graphing problems with unit rate, what we need to do is use our input-output table, where x's are your inputs and y's are your outputs, and then you can create an ordered pair of the two. So let's do this. It gives us our instructions right here. We need to first identify the unit rate, 2, create a table of values, an input-output table, 3, write our ordered pairs, and then 4, we will go to the next screen and graph this relationship. All right, let's get this table done. So it gives us our input, okay, and it tells us right here that the tickets to an amusement park cost $35 each, okay? So what does that mean? If I have 1 ticket, how much does it cost? That was our given, 35. So for our ordered pair, we're just going to write 1, 35. We can drop the $sign for our ordered pair. Now 4. How much will it cost for 4 tickets? Well, this will simply be 4 times 35 because it's 4 tickets at $35 each. And if we multiply 4 by 35, what do we get? I'm not plugging it into my calculator as we speak. Okay, maybe I was. That's $140. So that means that our next ordered pair will be 4 for the X, 140 for the Y. Go ahead and drop the $sign in your ordered pair. And then last but not least, the huge family. They have 7 people that are coming to this amusement park. Well, we would just need to multiply 7 by our unit rate of 35. And I go 35 times 7, or 7 times 35, and that gives us $245. So our final ordered pair is going to be 7, 245. See you on the next slide. All right, now that we're on the next slide, we can see we have all of our ordered pairs. We have 135, 4, 140, and 7, 245. First step is we are going to plot these ordered pairs. So my first one is going to be 135, and look, I going up in increments of 100 here. So I just got to do some guesstimating. So I know that 35 is less than halfway, so my first mark is going to be right about there. Let me grab my pen. Right about there. Hey, good enough. These do not need to be perfect, guys. They do not need to be perfect. Now that one's done. Let's check it off. Next one we're going to deal with is 4, 140. So I'm going to go up to 4 on my X, and then I'm going to guesstimate where 140 would be, and that'd be roughly a little tiny bit less than halfway between 100 and 200. So my next point's going to be right about there. Mark that in with my pen. And remember, guys, these do not need to be perfect. And then last but not least, let me check that last one off. Boom, we're done. Last but not least, I have 7, 245. So I'm going to go all the way up to 7. And then I'm going to guesstimate about where 245 would be. And that would be kind of midway between 200 and 300. About right there is where my last point's going to be. So I'm just going to go plop that in there. And then last but not least is our line. But stop. Stop. I know we talked about putting arrows going both ways, but this is a real world problem. Can we ever have a negative number of tickets? No, we cannot ever have a negative number of tickets. That's why our graph only shows us the positive quadrant 1. So for these particular problems, we start at 0. 0 tickets would be $0, and then we just go up, 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 up. But we do put the arrow at this end. Oops, let me get my highlighter. At this end, because this line will go on forever. Now, look at how imperfect my line is, guys. We don't need to be perfect. We just need to show the trend. Okay, this is as good as you need to do with your graphing. All right, guys, it's class kick time. This should be class kick slide number 2. I wanted to keep it kind of sparse since you guys are doing this lesson today off of YouTube. All right, so for this next one, we are going to find the unit rate for 1 rose, okay? So we have roses cost $28.80 per dozen. Now, first of all, how many is in a dozen? And no, I'm not talking about a baker's dozen. I'm talking about a normal plain dozen. 12. A dozen is always 12. Side note, a baker's dozen is 13 because they give you an extra donut. But a dozen is always 12. So that means to find our unit rate, let's first set up this rate. So we have $28.80, and that's going to go on top, okay? So we're going to be setting up it's going to be dollars to roses, okay? Dollars to roses. So I have $28.80 to 12 roses because there are 12 in a dozen. But I want to know, what is my dollar cost for 1 rose? And that will become our unit rate. So first things first, we need to find that unit rate. And I'm going to do that simply by dividing 28.80 by 12. And 28.8 divided by 12 is 2.4, or $2.40. This is our unit rate. When you get a 1 for your denominator, your unit rate is your numerator. So I have a 1 on bottom. This will be my unit rate. Okay, that means that if x is 1, then y is $2.40. We're already filling out the table. Make an ordered pair, 1, comma, $2.40. Close parentheses. Now for this next one, we need to find 3 when x equals 3. But check this out. We can create another fraction and put 3 on bottom. So what do we multiply 1 by to get 3? Well, 1 times 3 is 3. So that means we multiplied this by 3, and we have to multiply the top by 3. So now I can find how much does 3 roses cost? Well, $2.40 times 3 equals 7.2 or $7.20. So 7.20, and then my ordered pair will be 3, 7.20. And for last but not least, 5, we want to go back to our unit rate. You don't want to mess around with that 3. We're going to go back to our unit rate. We're going to go 240 over 1, and we want to know what our numerator would be when our denominator is 5. Well, we multiply by 5 to get that. So we're going to go $2.40 times 5 roses, and that gives us an even $12. So for 5 roses, the cost is $12. For our last ordered pair, 5, 12. And you know what? I'm going to go ahead and put the dollars and cents in there just to keep that consistent. Now let's graph this, guys. So we can see here all of our data has been transferred to this table, and all we need to do is plot 1, 2.4, 3, 7.2, and 5, 12. All right, so first things first, we are going to be plotting 1, 2.4. So I go from 1, and then I go to 2, and I just guesstimate about halfway in between is where 2.4 would lie. Remember, guys, we don't have to be perfect. And then for the next one, I'm going to start with 3 on my x line, and I'm going to go up to 7.2 on my y. So I go 3, and then 7.2 is going to be just above the 7. So here, let me grab my pen. And my next point will be like right about there. And then 5, 12, this is an easy one. We just go 5 on the x and then all the way up to 12 on the y. And then you can see these are lining up quite nicely. That's quite nice, quite nice. So 0 roses would be $0. Oh, except I can't draw, you know. This is going to be a tough one to write. Okay. So 0 roses will be $0, and then we're just going to pretend that Miss Hill's line is perfectly straight. Hey, that's not half bad. And I notice here there is no negative. There's no negative because we cannot buy a negative number of roses. You certainly don't owe anybody roses. So there's no negative numbers on our graph. And remember, guys, your lines don't have to be perfect. They really don't. Look at mine. All right, now we're going to be talking about determining the greater rate of change. And honestly, when we want to determine the greater rate of change, we're finding that unit rate. That's exactly what we're doing. And the one with the bigger unit rate has the greater rate of change. That's it. Let's do this. All right, guys, what we're going to be doing here is we're going to be finding the rate of change or the unit rate. We want to compare these rates of change. And you'll see here, this is a table and this is a graph. How can we compare a table and graph? Well, it's actually a lot easier than you think, okay? So we're going to look at the next following slides, and it's going to show us how we find the unit rate for relationship A and the unit rate for relationship B. Let's take a look. So first, let's look at relationship A. Now, if we find a unit rate for these relationships, then we can compare their unit rates. It doesn't matter if one's a table and one's a graph. Now, if we look down here, and sometimes this is overkill, but in these early stages, you definitely want to take a look at 2 of them. So I have my first ordered pair of 294, and remember I put my y value on top and my x value on bottom. And then I have my second ordered pair of 5, 235, but I have my 235y value on top and my 5x value on bottom. Divide these through as division in disguise, guys. Try it now. You're going to get 47 for each of them. That means that the overall unit rate for relationship A is 47. And then let's take a quick look here at relationship B. This is the one that they gave to us on the graph. Again, we're just going to pull the two smallest values, 156 and 7, 237. I'm going to make two fractions with my y values on top and my x values on bottom. It is getting late in the day, guys. All right, and when I get 156 divided by 4, that is 39. 273 divided by 7, same thing, because it's the unit rate for this graph, also 39. Now let's make our comparison. Now, we can't do this live in class with our cool Engagely QR codes, but you guys, which one has a greater rate of change? Pro tip, hint, hint, which one has the bigger unit rate? Yeah, Captain Obvious answer, guys. It is A. It is relationship A. Relationship A had a unit rate of 47. This person typed 47 words per minute. Unit B had a rate of 39. They've typed 39 words per minute. Which is faster? 47. All right, guys, this is the last thing we're going to talk about is going to be, is it proportional or is it not proportional? And I will tell you this is an easy one. It's related to grabbing two or more values from your chart. Now, what we're charged with finding here is if this table shows rates that are in a proportional relationship. If the relationship is proportional, the unit rate will be the same for all ordered pairs. So all we need to do is set up our ordered pairs with our y's on top and our x's on bottom. See y over x, y over x, y over x, y over x. And then we can find their unit rates. So I'm just going to grab my calculator real quick because I want to make my life easy this afternoon. And I'm going to go 0.5 divided by 2. That's what the first one says. And that gives us 0.25. 0.25. So I'm going to say this right now. If this is proportional, these will all equal 0.25. If it is not, if we get one number that is something else, then we throw the whole thing out. It is not a proportional relationship. So let's do the next one. 2 divided by 4. 2 divided by 4. And look at that. What did we get? 0.5. Frankly, we don't even need to continue. No, it's not a proportional relationship. No. Nope. But let's just say, for laughs and giggles, that we didn't find that and we started at the bottom maybe. Let's check the next one. Let's check 5.25 and see what happens when we divide that by 7. Oh, we get 0.75. This is even worse. These don't even match. All right, let's find the last one just because. So I'm going to go 9.6 divided by 12, and that's 0.8. Look at this, guys. All of these are different. This is not proportional. Line, 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 line. Okay? So remember, all of the unit rates must be exactly the same number for a relationship to be proportional. Okay, guys, and let's see. We want to determine whether the relationship is proportional or not proportional and explain why. Okay, so we're going to take a look at these terms. We need to turn them into fractions of y over x for each of our ordered pairs. So the first one will be 30 over 5. The second one will be 72 over 12. Then we'll have 18 over 108. And then lastly, we'll have 120 over 20. All right, let me get some equal signs in here because we are going to find their unit rate. And we're going to find it through division. So I am just going to first divide 30 divided by 5. That'll get me the unit rate for this first ratio. It is 6. The rest of these all must be 6 for this to be proportional. 72 divided by 12 gives me 6. So far, so good. Yay, yay. Let's try the next one. 18 divided by 108. Did I write that correctly? Is anybody yelling at me yet? Ay, 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 ay. 108 over 18, crazy lady. 108 divided by 18 equals, oh, guess what, though? Guess what? It's 6. And then if we go 120 divided by 2, you might already know this one. 120 divided by 20 is also 6. So, because these all have the same unit rate, means they are all proportional. All right, guys, your exit ticket is coming up next. But just remember today, complete 3.04. And I did make today's quiz a bonus quiz since you're learning from a YouTube video and had no teacher for today for math. So be sure to take that bonus quiz and get yourself some good bonus points in math, guys. All right, here's our exit ticket. And of course, it's dealing with the unit rate. All right, go ahead and pause. I'm going to read it and then pause and then wait 3 minutes, push play, and find the solution. So the exit ticket today is, in a salsa recipe, the number of tomatoes added is proportional to the amount of salt added. Ooh, salsa, tomatoes, salt, delicious. This graph shows that relationship. Oh, so even if we wanted to make 100,000 cups of salsa, we would be able to know how much salt to put in depending on the number of tomatoes. What is the unit rate for the number of tomatoes to teaspoons of salt? I don't even think you'll need 3 minutes for this. I'm going to tell you right now, guys, the answer is on the graph. Pause now. All right, you must have already found it. And if you did, then pat yourself on the back, okay? So we want to know how many tomatoes do we put in per teaspoon of salt. Well, look at this. Teaspoons of salt. 1 teaspoon of salt gives me, oh, look at that ordered pair. 1 teaspoon of salt gives me 3 tomatoes. Or we use 1 teaspoon of salt per 3 tomatoes. So the answer here is simply 3 tomatoes per teaspoon of salt, or 3 tomatoes over 1 teaspoon of salt. Now, you guys, what we've been doing today, we've also been finding something called slope. Slope, or the constant rate at which a graph increases or decreases. Remember this guy's name. We're going to talk about him tomorrow, and we're going to talk about him a lot. But for now, go on, go forth, take your bonus quiz, and have a wonderful day. I will see you guys tomorrow. Bye.